Okay, next in our series of amazing videos by Dr. Gosher is going to be standard additions. And in this case, it's different from internal standards because in standard additions, what you have is you have matrix effects. Dun, dun, dun. Okay? Matrix effects are not particularly happy. What that means is that your calibration curve that you made and attempted the first time around ends up not working. And hey, I just realized you couldn't see what I just wrote. Okay, so we're doing standard additions because we found matrix effects. Now, practically speaking, what does this mean? This means that you have some sample in a cute flask, okay, sample, and you're going to measure it. This is step one. Measure your sample without doing anything to it. And let's say we measure it, and let's just say we're doing spectroscopy, because spectroscopy is awesome, and we know everything about it now. So we measure it, and we get an absorbance of, I don't know, 0.158. That sounds like a nice number. And that is arbitrary units, because absorbance has no units. So we measure it, but we know we have matrix effects, or at least we suspect we do. And so now we need to spike it. Okay, so next up, spike. How much, you might ask? Well, first of all, you have to have a feeling of what it is that you're analyzing. So, I don't know, let's take something jazzy like arsenic. Arsenic is always fun. So it's a sample of arsenic. We don't know how much there is, but we know that arsenic absorbs at a certain wavelength, and so we've set that up. So now we have to spike it, and things get real now, because you have to know how many milliliters of your sample, the original, you're spiking. So let's just say that we take 10 mils of our unknown, and we do that with nice glass water. So that's actually like 10.0. We know the volume. And then perhaps we take then 50 microliters, small volume of a concentrated standard of, let's do 500 part per million arsenic. And we add that in there. And then we measure it again. It's mixed together. We're going to get the absorbance again, and we come out with a new number. And I am totally making these numbers up as I go, so I hope that this works out well. But let's just say you measure it again. You've added arsenic, so the absorbance should increase. And so let's just say we get 0.283. So we spiked it with a lot because the absorbance went up by a lot. So now we have to figure something out. So we can say that the concentration originally was proportional to this absorbance, and then the concentration afterwards was proportional to that absorbance. So there's actually a nice equation for that that's already been done out that says concentration, might as well say arsenic, initially, right, this is it, is going to be proportional to its intensity. So intensity of arsenic, right? And then over that is going to be the new concentration and the new intensity. So that's an I. And then this is going to be standard plus unknown. So I'm undoing my cut. Okay, I got my brain back. So what we're doing is it's concentration initial equals intensity of that, right? And then you have intensity of the standard, which is the same thing. So I'm not entirely in love with the way this is written. Standard final plus your unknown final. Okay, so what's up with the final? The final is, hey, I diluted it because I put in some extra stuff, so that's why things end up being final. And S is this spike, your standard that you added, and then X is the original. They're all arsenic, okay? And so the S versus X is a little bit arbitrary. But we can do this. We can put these numbers in. And the way that we can put the numbers in, the right-hand side is really easy. So this was me making a mistake. I will initial that and date it, right? Because that was a single line cross out, and I would get points off right there for scribbling. So we don't know what X initial is. No clue. But we know what I is. We know that we got 0.158. And we know that the intensity afterwards with the standard and the unknown was 0.283. So the right-hand side of this equation is easy, not a problem. X initial is actually our ultimate goal, so I'm going to leave this in those units. And then everything else we can figure out. XF is going to be proportional from M1V1, M2V2, okay? And so we know that we had 10 mils from this spiking of Xi. And then that became 10.05 mils times XF, correct? 50 microliters is 0.05 mils, okay. So this is sensible, this is reasonable, we can totally do this. And that means that where XF shows up here, we can just rearrange for Xi. So Xi and XF are related. So, all right, XF shows up in this equation. I want it in terms of Xi, no problem. It's 10.0 Xi over 10.05. Not a big deal. So I put that right here. Okay. And then what about the standard? Well, that's super easy because we even know numbers. So now we know that originally the 50 microliters, the 0.05, 0.05 times 500 ppm, it's going to equal then 10.05, that's our new volume, times I don't know what. And then we can rearrange, okay? So that's 0.05 times 500 divided by 10.05. 2. So this becomes 2.4875. Okay, so we look at this and we see that we have one equation, we have one unknown, which is X initial, which is our initial concentration of arsenic in our sample, which is what we want, and now we just have to do a little bit of math. Okay, so I know, if you didn't like math, you probably don't like analytical chemistry that much, but that's life, we all have to deal with it. Why don't we collapse some of these numbers down? So we're just going to start calling this X, so it's X over 2.4875, plus I'm going to go ahead and divide the 10 divided by 10.05. So that's 0.99502x, okay? And that then is the 0.158 divided by the 0.283. Sweet, 0.5583. You'll notice I'm not paying particular attention to sig figs right now. I'm just getting the numbers and then we will end up rounding at the end. So this is not a problem. I'll multiply everything by this to get it over here. And so X equals the 0.5583, I have to multiply by the 2.4875. So I'm just distributing this. Okay, so that's 1.3887. And then I'm going to multiply the 0.5583 times the 0.99502. You never thought watching somebody else use a calculator in a video would be this fun, did you? Okay. We've got numbers, and that's X, and then, oh, yay, now you can see what we do because we just wanted to subtract this portion from both sides. Okay, so we've got X minus that. Hey, that's 1X minus that. This is cool. I can see where this is going. I'm sure you can. Okay, I'm getting a little punchy, but that's okay. We're doing math. We're doing math. Okay, so 1 minus that. We have 0.448. X equals 1.3887. Okay. And then X equals 1.3887 divided by 0.44448. Okay. X equals 3.124 ppm of arsenic. That was the original concentration. Sounds good, right? Logic check, always end with a logic check. We think about the proportion. We think, okay, 3.124 gave us 0.158 absorbance. We know that we added 2.48, arsenic, and that increased the absorbance from 0.158 to 0.283. And so these seem reasonably proportional, and I would go with a happy face. Okay, that's standard additions.